Hi, this is Nicola again. So this is a sample assessment material for the A-level statistics exam, and this is paper 1, and we're going to have a look at question 8, which is all about experimental design. So a trial was carried out to investigate the effect of an antibiotic treatment, amoxicillin, for an acute ear infection in children aged between 6 months and 2 years. Details of the design of the trial were stated as follows. After we obtain consent, the children were randomly assigned to treatment with amoxicillin or with a placebo suspension with the same colour and taste. So the suspensions were supplied to the participating doctors in a double-blind fashion with 2-block randomisation. Doctors, patients and investigators remained blinded throughout the study. Explain in the context of the trial, so this was really happened in 2000, in context of this trial, the purpose of the random assignment to treatment. Okay, well the random assignment to treatment means that there is, the whole idea is that there is no bias will exist in assigning the treatment to a child. Okay, so random assignment, so no bias. And the bias means, for example, that you could have, which means situations such as for example, so such as parents desperately wanting their child to have treatment and not placebo. They could try to pressurize the doctors. And doctors are only human, so it must be very difficult for them if they know that there is a particularly sick child and they're giving them the placebo. That must be awful. And and if someone's not as sick, you think would last longer, they're getting the treatment. But the whole idea behind the randomised thing is that, you suggest it's randomised, there's no idea, no conflict of interest, and it avoids any bias towards a certain child or towards a certain patient. Because you can do it as well, the doctors may just be interested to see that their treatment works, so they might give it to the less sick child, which sounds really awful, but that's an option. The next question is a double-blind trial. So the purpose is to avoid expectations. So that's kind of to avoid bias, and this one too is to avoid any expectations. And that means both for the parents and children, expecting to get better faster than the other ones, perhaps, faster than other people. So trying to avoid that, and also to ensure, so if you were a doctor, so if the doctor knew a child was on the placebo, they may treat them differently. Even unconsciously. Accidentally, but it may happen, and the patient, will respond to that. They will realise. So to ensure that all children are treated the same, regardless of whether they're on the antibiotic or the placebo that's being given, and medical staff, and they don't care about the recovery rate. That's not important. So you would think if somebody's on the antibiotic, they get better quicker, but those expectations or whatever you're looking for are gone. So you're kind of psychologically not taking those things into account. Next page. B. Explain how a randomised block design could be set up for this trial, and why this would be preferable to a completely randomised design. You should include a diagram in your suggested randomised block design. Yes, they have. Okay, so they had suggested, I think in the question, let's go back here, in the question, if I can read it, 2-block randomisation. Parents, doctors and investigators remained blinded throughout the thing. Okay, so the whole idea of a completely randomised design means there's just one treatment, so you'd only have one thing. So a randomised block design means you can take other factors into account. So completely randomised is a one-factor design, i.e. testing the treatment. So it would only be antibiotics and placebo. But if you did a randomised block design, you could include another factor that may affect their treatment. So you could have perhaps age of the child. Will that affect? So if they're having the same amount of antibiotics, does the age of the size of the child affect how quickly they get better? Or do they have other medical factors, medical conditions? Have they got other things that are happening to them that aren't good? May affect the outcome, and so most important of these should be taken into account. So it may affect what's happening and whether we consider that the antibiotic is working or not. Significantly different to the placebo is what we're working. So these may affect the outcome of the trial. Because, remember, if you include an extra factor, it takes out that variability from the error part of an ANOVA test, which means that your error, sums of squares, is smaller, so that when you're trying to find your F test stat, you divide by a smaller value, which gives you a bigger F value, test statistic. And then that means that if a difference exists, it's much easier to detect. So if we're looking, we definitely want the amoxicillin, if I can press, I can't, and the placebo. And maybe, given what we're saying, so that's your one factor there. So this is the factor, the treatment factor that we're interested in. And then we need to have another one. So maybe, what do we say, the age of the child we could do? Or you could do how severe, like we were saying before. If it's a mild infection, then the antibiotics might work quicker on it. So you could have, I'll do like the mark scheme, we've got mild, moderate, and severe infection. Okay, or you could have ages. You could have 0 to 2 years, and then 3 to 5 years. How old? Oh no, what were the years we were doing? It was only 6 months to 2 years, right? Let's change that. So we go 6 months to 9 months, 9 months to a year. 1 to, maybe we could break it up into just 3-month sections. So 9 months to a year, so 1 year to 1 year, 3 months. 1 year, 3 months to 1 year, 6 months, etc. So that would be fine. We could do the age, sorry, that's down there. So a completely randomised design could result in the children with mild infections being allocated amoxicillin for example, this would give a result that may not indicate the effectiveness of the amoxicillin. So if we, obviously these people you would expect to get quicker, faster anyway, and if they've got the amoxicillin or not, it might or might not make a difference. So it's where the amoxicillin makes the biggest difference is what we're really looking for, and if it's significantly different.